So we are going to see geometrical isomerism in alkenes. Okay, so this is a type of isomerism where it is a type of stereoisomerism. Please make a note. It is a type of stereoisomerism where the isomerism happens due to restricted rotation along the double bond. Okay, so the rotation will be restricted. If it is not restricted, it is conformational isomerism. If it has a restricted rotation along the double bond, it is called as geometrical isomerism. So let me take an example. What is the name of this molecule, ma? CH3, CH double bond, CH single bond, CH3. What is the name of this molecule? Butene. Rifa, am I audible?
Yes, sir.
கேட்ட கேள்விக்கு பதிலே வரலையே. So butene is what? Cis-2-butene or trans-2-butene. So how to write this? So first take that central carbon, C double bond C. Another molecule also you can write, very similar setup. I'll give different colors for hydrogen and methyl. So if the hydrogen is on the same side, or hydrogen can be in the opposite side. Okay. Similarly, the methyl group will be in the opposite direction, or the methyl group will be in the same direction. So this is a cis isomer. This is a trans isomer. So again we'll go for evaluate yourself. There are two types of propene. So one is 1-chloropropene, another one is 2-chloropropene. So the double bond can be here or it can be here. So, okay. So write the remaining with the hydrogen. CH3, CH, H, CH3, CH2. So among these two, which one will form isomerism is the question. So this will form, this will not form, because in the another carbon there are two hydrogen, two different groups are present, only geometrical isomerism will come. So can I write like this? I can write this molecule in two different forms. So I can have hydrogen on the both the sides, or hydrogens in the opposite direction. Meanwhile, one side the chlorine can be here or it can be here. The other side you have a methyl group. So if methyl and chlorine are on the same side, look at this, or hydrogen is on the same side, opposite. So we call this as the cis isomer. This is trans isomer. If you write in this molecule, one side automatically you'll get two hydrogen which are similar. So whatever you make the change, nothing is going to make a difference. So 1-chloropropene exhibits geometrical isomerism, while 2-chloropropene doesn't. Please make a note, ma. Preparation of alkenes. So when I say preparation of alkenes, number one, you can prepare it from alcohols. So you take the example, let me take ethanol, CH2H, CH2OH. So just you have to heat it with concentrated sulfuric acid at a very high temperature of 430 to 440 Kelvin. What will happen? This bond goes here, this bond comes out. So HOH is called as water. While you get CH2 double bond CH2. What is this called? Ethene. This is ethanol. Similarly, you take CH2, CH2H, OH, just treat it with Al2O3 at 623 Kelvin to 723 Kelvin. If you heat, the bond gets shifted and you'll get CH2 double bond CH2 plus water. Copy this now.
Copy.
Now we'll go for the preparation of alkenes from alkynes. So from alkynes. So this time I'm going to take an example called CH3 C triple bond C CH3. What is this molecule called? Butene. Now you can treat it with two ways, ma. One way you can add palladium in presence of hydrogen in presence of calcium carbonate. Another example, you can use NaNH3. Here also you will add hydrogen. In the first case, please make a note. In the first case, what will happen? The hydrogen will add on the same side. That means both the hydrogens that you added will be added on the same carbon in the same direction. While in the case of sodium in ammonia, the hydrogen will join in the opposite direction. Thereby, the methyl will be in the opposite direction in the second case, while in the first case it's in the same side. So this is butene. So this catalyst palladium will give you cis 2 butene, while this will give you trans 2 butene. And there is a name for the reagent. This is called as Birch reduction or Birch reduction. This is called as Lindlar's catalyst. This is also called as cis addition. What do you call that as? Cis addition. This is called as trans addition. Copy, ma. So from alkyl halides, if you heat it with alcoholic KOH, you will get ethene, where the hydrogen will be taken up by the OH and forms H2O, while the K will take the Cl. In vicinal dihalide, That is, we are going to take this molecule is called as chloroethane. What is this molecule called? This is 1,2 dibromoethane. This molecule is called as ethene. This is also ethene. So in both the case you get alkene. In the vicinal dihalide, the 2 bromine will be absorbed by the zinc and form ZnBr2. When you heat it in presence of methanol, you get alkene as the major product. Zinc bromide is the byproduct. Copy this, ma. In your evaluate yourself question, there is a question, ma. How do you prepare propene? They are asking, how do you prepare propene from 1,2 dichloropropane? Dichloropropane. Just add zinc and add methanol and heat it strongly. What will happen? Plus ZnBr2 will be obtained. Make a note of this, ma. It's a evaluate yourself question. So this is 1,2 dichloropropane. This is propene. Copy this, ma. So this method is called as Kolb's electrolytic method. So for this I'm going to take dipotassium succinate or potassium succinate, CH2 COOK, CH2 COOK. What is this called? Potassium succinate. So when you put this in the water, what will happen? It will form CH2 COO minus, CH2 CO minus plus 2K plus. Okay, this is succinate ion. Now you take the at anode, what will happen? At anode, oxidation takes place. What is oxidation? Loss of electron. So what will happen? CH2 C double bond O minus, CH2 C double bond O minus. So now let us see what are all going to come out at anode. So these two will join, these two will form, these two will form. So you'll get 2 CO2 plus 2 electrons plus CH2 double bond CH2. Please make a note. This is called as Kolb's reaction. Physical properties of alkene. So please make a note, ma. Ethene, propene, butene are all gases. Okay. The next 14 members, that is from pentene, they are all liquids. So higher members are solids. That to normal, they are called as waxy solids. So wait, another important aspect, odor. All are odorless except ethene. It has a very sharp sweet smell. Third point, their melting point and boiling point increases with increase in carbon chain. Increases with increase in carbon chain. In that also, straight chain alkenes have higher boiling point than branched chain alkene. Can I give you an example, ma? Copied, amma?
Yes, sir. Copy.
I'll give you an example, ma, for branched alkene and straight chain alkene. I'll give you an example. It will give you a better understanding. Because whenever the branching increases, the surface area will automatically decrease. Whenever surface area decreases, automatically you will find the boiling point getting decreased. So you take any example, for instance. மம்மி கதவை சாத்திக்கோ இல்லை மியூட் பண்ணி பேசு, கிளாஸ் போயின்னு இருக்குது. Copied, amma? Can I move forward?
Yes, sir.
And the last property would be solubility of alkenes in water. They are not soluble, or they will be slightly soluble. They are either not soluble or slightly soluble. Made a note of all the points?
Yes, sir.
So this cold alkaline KMnO4 is called as Bayer's reagent, When that is added to an alkene, what will happen? The CH2 will be there, nothing will happen to it, while both the carbon you get 2 hydroxy group. This is called as ethylene glycol, or otherwise called as ethane 1,2 diol. So let me repeat what all we have seen. We'll check once again. So we have ethene reacting with water to give ethanol. So ethene reacts with HBr to give bromoethane. With HCl it gives chloroethane. With sulfuric acid it forms ethane bisulfate. When it is treated with alkaline cold KMnO4 at 273 Kelvin, which is also called as Bayer's reagent, gives you dihydroxyl group. Copy this first. You copied all these reactions before?
Yes, sir.
Now copy this one. Now we will get into the details of addition of alkyl halide to alkenes. So we are going to see in detail. We saw few reactions, now we are going to see in detail. Remember, when I say HX, HX can be HI, HBr, HCl and HF. Remember, HF is least reactive, or you can even say it is unreactive. You can even use the word unreactive due to hydrogen bonding. So the reactivity increases in this direction. So reactivity increases for HX, because whenever size of the X increases, bond dissociation enthalpy increases. This is with respect to HX. Alkenes are of two types. Number one, symmetrical alkenes. Number two, unsymmetrical alkenes. Example, CH2 double bond CH2, CH3 CH double bond CH CH3, CH3 C CH3 double bond C CH3. These are all symmetrical alkenes, where both the side of the double bond same group will be there. Check both the sides. If you just draw an imaginary line like this, you will find both the sides same group are there. Such a molecules are called unsymmetrical alkenes. So you can add H and Br on either side. So when you want to add H and Br, both the sides you add, you get the same product, no change. But when you add HBr to unsymmetrical alkene, you have to follow a rule called Markov-Inkov's rule. Please make a note. Over book over spelling they are giving ma, so it's called as Markov-Inkov's rule or Markov-Inkov's addition. What is it called? Markov-Inkov's rule or Markov-Inkov's addition. Markov-Inkov's unga book lo kutturukan, so you follow that. So what does this rule states? Write down. When an addition reaction done on an unsymmetrical alkene, the negative part of the addendum joins carbon with less number of hydrogen. Please copy, ma. We have already learned the addition of HBr and HCl in symmetrical alkene. Look here, CH2 double bond CH, HBr and HCl is added, you get two products. On either side you add H or Br, you get the same product. But when it comes to addition of an unsymmetrical alkene, there are two products possible. Shall we see that first? Take the example of CH2 double bond CH single bond CH3. This is propene. So when you add HBr, remember this is negative, this is positive. Okay, so it can add on either side. Either it can add up to CH2 single bond CH single bond CH3, CH2 single bond CH, CH3. So the hydrogen can join in the terminal carbon, or the hydrogen join in the second carbon. If so, the bromo will join in the second carbon. If the hydrogen joins in the second, it will join in the first carbon. So there are two products. What are the two products here? So this is 2-bromo propane. This is 1-bromo propane. So in these two, which is major, ma? This is major, this is minor. Why that is major? Look at the Markov-Vinkov's rule. It states that when you do an addition reaction to an unsymmetrical alkene, remember you draw a line here and check on the double bond, both the sides different groups. So it is an unsymmetrical alkene. So which is the negative part here? Here the negative part is the Br. So they say that the negative part adds up to the carbon with less number of hydrogen in an alkene. So here you have two hydrogen, here you have only one hydrogen. So the negative will go to the central carbon as per Markov-Vinkov's rule. Copy this, ma. So let me repeat the mechanism. Step 1, carbocation formation. So the propene, the double bond gets added up to the hydrogen. Thereby you get something called H plus will be added to the central carbon. You will get a positive charge in the terminal carbon. Or if the hydrogen is added in the terminal carbon, you will get a positive charge in the central carbon. So thereby what will happen? A primary carbocation is formed if the plus is formed in the terminal carbon. If the plus charge is formed in the second carbon, that is the central carbon, you get secondary carbocation. Secondary carbocation is more stable because methyl is a plus I group. So it will give more electron, thereby it is stabilized. Step 2, what is happening? The bromide ion or the nucleophile will go and attack the primary carbocation, thereby you get 1-bromo propane, which is a minor product. While in the second example, the bromo goes and attacks the central carbon, thereby you get a 2-bromo propane. Please make a note, this 2-bromo propane is major, 1-bromo propane is minor, because we all know that secondary carbocation is more stable. Is that clear? Any doubts or any explanation required? Hydrohalogenation reaction. So in our textbook they have given an example of but-1-ene. So let me give you the mechanism for hydrohalogenation halogenation of 1-butene. So let us take the butene and then we'll just do one by one. CH3, CH2, single bond CH, double bond CH2. This is but-1ene. So step number 1, you should add H plus. So the electron will go and attack. So you get two products where all the hydrogen can join, either in the central carbon here, and thereby you get a CH2 plus in the terminal carbon, or the hydrogen can join in the terminal carbon and you get a positive charge in the central carbon. And remember, this is a primary carbocation, this is a secondary carbocation. Remember, secondary carbocation is more stable. Yes or no?
Yes.
So this is step 1. What is step 2, ma? Attack of nucleophile. So what am I going to do? I'm going to take the same set again. Now you treat this with bromide ion. So that will attack. If it attacks the terminal carbon, you get one bromo or two bromo butane. 1 bromo butane. This is 2 bromo butane. So which is major, ma? This is major, this is minor. Copy, ma. Hydrohalogenation of but-1ene.
Complete, sir.
Right. One more example in your book they have given. I'm taking that also. Write down. Hydrohalogenation of 2-methyl (3-methyl but-1ene). What is it called? 3-methyl but-1ene. How do you write the name, ma? How do you write the structure? 4 carbon, double bond here, and third carbon there is a methyl. What is the step number 1, ma? Protonation. So it can attack here. It can give 3 types of ions. Let me show you one by one. First type, the hydrogen can join in the terminal carbon. So thereby you get CH, single bond CH. The hydrogen gets added here, so you'll get a CH2. So plus will be here. So this is one type where the hydrogen join in the terminal carbon. Another case is also there where the hydrogen can join in the second carbon. So you'll get CH3, CH3, CH2, CH2 plus. Okay. Now what will happen? Please make a note. So these are two options. Another option, this hydrogen will jump here. This is called as 1,2 hydride shift. So you'll get CH3C, CH3. Since the hydrogen has jumped there, you get something like this. So now look, what are all the carbocations? You have primary carbocation. This is secondary carbocation. This is tertiary carbocation. So which will be major? This is major. This will be minor. While the first one will be found in traces. The first one will be found in traces. Okay, this is very, very important, man. The point, please copy. So just a moment. Now take all of them and rewrite it here. So we know this is minor, this is major, or you can simply say this is more stable, correct? So now to this you add bromide ion. So what will you get? Now look at this, ma. Wherever the positive charge is, in that place what will come, ma? The bromide will come and attack. So here it is 1 bromo, here it is 2 bromo, here it is 3 bromo. So you can write the names also. What is the name of the first molecule? 1, 2, 3, 4. Please be careful while writing it, ma. See, I have made a mistake. I have added one bromo extra. You should not do that. So this is 1 bromo 3 methyl butane. So it will be very less in quantity. What about this? How do you name this one? 1, 2, 3, 4. So it is called as 2 bromo 2 methyl butane. This will be minor. Which will be the maximum? The last one. 1, 2, 3, 4. 2 bromo 2 methyl butane. This will be major. Copy, ma. So this is there in the textbook, okay, but not so much clarity is there, so you write it with clarity. See, last time what did we see, ma? What was the reaction that we saw? So in this reaction, we call this reaction as Karash effect. Ediko, ma. It's called as Karash effect, or it is called as the peroxide effect. Na effect? Peroxide effect. என்னம்மா நான் சொல்கிறது கவனிக்கிறியா? Are you listening? I am asking you a question, you are not answering. What's going on? So in this case, what will happen? CH2, double bond CH, single bond CH3. Propene is there. Now, last time we just added HBr, correct, Amma?
Yes, sir.
This time we are adding HBr in presence of organic peroxide. ரொம்ப முக்கியம். So this is propene, undoubtedly. Again you will get CH3, CH, single bond CH3, CH3, CH2, CH2. So you get 2 bromo or 1 bromo compound. Correct, Amma?
Yes, sir.
So you get both the products, Ilyama. 2 bromo also you'll get, 1 bromo also you will get. So 2 bromo and 1 bromo you'll get. But last time which was major, ma? Without peroxide?
CH3.
அதுக்கு பேர் இல்லையாமா?
Don't know the name.
புரியல.
Don't know the name.
What is the necessity of allowing you to copy the question and answers, ma? What is the use of showing you the notes for such a long time? Why you didn't make a note? Why you are not making note of the names, ma? Papar பேர் கேட்டா சொல்ல தெரியல பார். So what is the name, ma? இப்ப பார், இப்ப தெரியுதா பார் போர்ட்ல? Which is major, which is minor? கரெக்டா சொல்லணும்.
2 bromo propane.
இப்ப எழுதிக்க முடியுமாமா? அதுக்கு தானே I showed you the videos multiple times. Each and every screen I am displaying. You are not making note of the names. இல்ல நானும் பேர் எழுதாமே போலாமே. Why should I write?
Wrote, sir.
So now you tell me what was major, what was minor in the reaction.
One.
Are you listening? Are you interested in the class first of all? Very basic questions only I'm asking, you are unable to answer. No, this is not right.
I can't understand the question what you are asking.
I am not asking nothing. Ma. Last time the HBr was added. Which was major, which was minor. This time what will be major, minor, I will tell. I already showed you the reaction. What you didn't understand?
Propane.
Then you should say I didn't understand the question. You are simply saying I didn't know the name. Disturb பண்ணிட்டே இருக்கீங்க.
Oh.
Ma, if you are not interested, I will cut the class. Ma, you can just go through the video and come later.